Sanding soils is good, you know, and when we get some rain, that if we get a lot of rain, it seems to dry up faster than the heavier ground, but it doesn't hold the moisture. So having that cover there is, you know, like a rye cover crop, that mat, it's just like mulch, you know, it sucks up some moisture and it'll keep it there. When you open that ground up, then it can dry out so much faster and you're losing your moisture. And you need that. I mean, 3 weeks ago we were underwater. We had a swamp and now we're in the Sahara Desert. We're begging for rain. But we actually spray liquid carbon on a lot of crops to help increase, you know, plant health, root systems. We found a lot mixing the liquid carbon with nitrogen when we're going over top of like small grains. It won't burn it, so we're getting a healthier plant and we're helping, you know, getting a better root mass from that. So building it up is definitely helping the root mass and increasing the yields. And when you get hot and dry, I think it helps with stress tolerance. So grid samples, so we take we're just using the example, say a 50-acre farm, and we'll break that down to 2-acre grids. And we'll pull a soil sample by GPS coordinate off that 2-acre grid. We can take that and then we can variable rate nutrients by that. So instead of taking one random soil sample off of 50 acres, it may say that you need 2 tons of lime. Well, you don't know that down, you know, if the soil type varies or maybe the crop's different, you may not need as much lime, potash, nitrogen. So you're just going off one sample, where now we have a sample off every 2 acres and we can apply to that 2 acres. So in some cases, you know, if you need 2 tons here, you may only need a half a ton down there. And if you're just in the middle, you're over applying on one end and under applying on the other. And you want to keep a level nutrient balance across all your acres. So you're better able to do that on a smaller grid. And it's saving time and money. I'm not buying inputs that I don't need and just throwing them out there. So it's money up front to get to that point, but then you can better manage your soil after that. So tissue sampling is where we go out once the crop's planted and we're pulling leaves off of there and we get them sent off to test, and we can see the nutrients within the plant so we can keep it adequate throughout the growing season, whether it's minor elements such as sulfur or magnesium, or major elements, you know, potash and nitrogen. And sometimes late in the season or after a big rainfall, you may get some nitrogen loss, and you'll need to add that. Some quick growing like vegetable crops such as watermelons need a lot of potash, and they're growing so fast that they're draining it you know, out of the soil. They're taking it up as fast as they're using it, so you need to, you know, supplement them somewhere. Through that tissue sampling, we can see a pretty instant snapshot of what that plant looks like today, and then we can build our soil or our nutrient base off of that. So variable rate is when we're taking that grid sample map and we know what our nutrient levels are, and as we're going across, we load a prescription into the application equipment, and as we're going across the field, it's changing the rate based on how much nutrients we need. So if we're looking for, say, 200 pounds of potash to the acre, it knows what's there and what we need, and it can change automatically as we're going across the field. The net is, you know, reduce input costs. We're not over applying, you know, especially on the nitrogen, you know, we're not putting too much where we don't need it, and it's maybe leaching or running off, or the crop's not using it, and we're able to take that to where we do need it. We've seen through some harvest yield maps, you know, you just have some soils that are just never gonna, no matter what you do, aren't gonna perform. And if you're dumping the nutrients out there and it's just not performing, you're just wasting money, you know, it's not being sustainable.